Okay, welcome back. Let's get going. What we're going to do now is implement our chunks. So we need to get our values out of our text boxes, TB columns, text, out into the columns. TB rows.text out into our rows. And for 2D, this is easier because it's simply our rows times our columns. And although we could loop through our chunks, let's go ahead and implement or use a function I don't quite have yet in here. Hold on. No reason to make this static. Column, the row, not the road, and the stride. And it's that simple for 2D. So this is going to return our index. What does it mean? We are making this column based. Our stride is going to be our number of columns. That's what we're going to pass in. If we wanted to make this row based, our stride would be our number of rows, and it would be column times stride plus row. Let's go ahead while we're here and implement the 3D version of this. Once again, it's column based. So we are looking at a method. The second method really is the prototype to keep on going up and up and up to other levels of dimensions. If you wanted to add another level, it would be like level size 2 and something like int w, and you would just plug that in up here in the front, and that would give you 4D. And then this is going to return the column, or excuse me, the index based on a column and row. But what we really need right now at this moment is to get our column and row from, or no, wait a minute, we've already done that. I'm jumping ahead, excuse me. This is exactly what we need right now. Let's go ahead and and as I said, if you wanted to make this row base, you would pass in row, and it would be column times stride plus row. But since we made it column base, which is normal left to right, we read either left to right or right to left. So it's column based first. And if by some chance I'm typing too fast here, you can just pause the video know this isn't brain surgery, but it seems that so many people are looking for it and they're not getting answers. So here's an answer for a big question that deals with level design in a very efficient and fast method. What did I name you? Or did I not name you? I didn't name you. I'm just going to say how many chunks we generated. Else rows invalid. Yeah. Columns invalid. So here in our Windows form world, this really does us no good unless we can get the value. So let's go ahead and do that right now. This time we'll pass in our column and our row instead. Fat fingers. All right. I'm doing a check here that I do not do when I'm in the graphics programming or game programming. Because if our index is invalid, we're already in a bad place. We've probably already crashed. And of course, we don't want to waste time on checks because every one of these if statements count a cost, and they don't cost that much when there's only one or two. But when you're talking about 1 million or 2 million or 5 million, chunks were out. There are that many chunks, and the index we were trying to get was that. So that's what our mistake was. If we have a mistake there. And now we're going to also that simply gets it. Let's go ahead and pump another button over here. Don't crash. Come on, Visual Studio. Microsoft is so persistently trying to get people off of Windows Forms. And I don't think they get it that this would be such a slower application. If we try to do it in WPF or Universal or even Console, this application would take forever to write and demo. Get the column and the row, fetch by, or fetch column row. There we go. And this go ahead and move this guy up to here. Grab our null check. If int.try parse tbindex.text out into the index, else tbmessage.text index was invalid. Get cr out. I don't have that yet, do I? No, I don't. I knew I should have added those in a little while ago. I tell you what, let's go ahead and test this out. And then we'll add this because we're going into another function type. So, I'll put some default values in there because I will. Come on. I will hit those buttons with nothing in there. And although the int try parse shouldn't crash, chunk count is 0. What did I do wrong there? Generate. Typo. We have 2,500 chunks, and I want to fetch the chunk at column 0, row 0. Boom. All right, so yeah. Now we have 1,250 chunks, and I want to fetch the chunk at column row, row 1. So that should be 25, 26, 26. Column 1, row 1, chunk index number 26. And that's directly from it. Okay, and one thing you have to be forewarned about this is, although we can't really mess up on our rows, the check does stop us from going too far on the rows. We can mess up on our columns because there is no column 25, but it instead gives us column 0 because there's 0 through 24 because since we're 0 base, so it goes to column 0 on the next row and goes one row up. So you do have to make sure that your column and row is within range. All right, let's get these other two functions in here where we want to get our column and our row. I'm screaming. Z remainder. It's not really a Z, but it's more of a Y here. Now this method is, there are some simpler ones you can actually find in the Win2D documentation or the Win2D examples from Microsoft. But this method is built to provide for multiple dimensions, to keep going beyond 2 or 3 dimensions. You could very well have some secondary information about your scene that is hidden, that you don't want to have loaded all the time, that maybe you save to file and then bring back or open up when something happens in your game or your application. So think about something like when a battle starts, you load some information about the defenses. So normally you only have the models loaded, but you don't have information about them. So it's not in RAM. But when you start to be attacked, it loads all the information. So that's the reason you might want to go beyond 3D. Have a 4th dimension. So the 4th dimension is kept either compressed with some of the .NET compression utilities, or kept on your hard drive until you need to use it. Okay. So there's our first method, or a 2D method for get column and row. Now, I'm going to generate. And we got chunk 0, which is at column 0, row 0, and there is what we requested. Here's the result of our get CR. So we have 50, so let's say 52. Chunk 52, that's on column number 2, which is correct, and it's on row 1. Boom. Then put scroll bars on here. So 108, 108, column 8, correct, row 2. That's it for 2D. Let's take a look at this one more time. I didn't really explain this. We are dividing our index by our stride, and we are we're getting rid of the remainder. That's going to be our row. We are removing our row times our stride from our index. That will give us our column. And if we're row based, we're just going to reverse this. This would be X remainder. This would be Z remainder. It would still be our column, our index that we're passing in divided by our stride. This would be X remainder minus equals to our X remainder to the modulus of 1. Why'd I do a float? I don't know. Could have done double, but of course float's more friendly to Unity and got it. And then this would be z remainder and our index minus our x remainder times our stride if we wanted to be row based, but we're column based. And we will use this in our next one. Let's go ahead and type in our 3D version of this. And then we will take a break before we return and do our 3D version. Like I said, not rocket science, but you just gotta know it. This time, for our y, we're going to start off with our y. And remove it from our index. Then we pretty much do the same thing that we've done before. Okay, so this time the only thing we do is we remove our extra dimension. We remove our whatever dimension above 2D off of our index. So if it's 4D, we would start off with our W remainder, then we would do our Y remainder, and then we would do our Z and X remainder. And that will give us our column and row based on, that will give us our column, our Y in our row, our X, Y, and Z based on the index on a 3D scale. And we will look at that working next in a few other things. See you then.